Once upon a time, in the quiet town of Newbite, there lived a curious teenager named Arya. She wasn't like most kids in her school. While others were busy with sports or music, Arya was fascinated by machines, especially the idea of making machines think like humans. Her curiosity began one evening when she asked her grandfather, who used to be a computer engineer, "Can machines ever think?" Her grandfather smiled and said, "That's what artificial intelligence is all about." Arya's eyes lit up. "Artificial intelligence? What's that?" So he began to tell her a story. Not a fairy tale, but a real story about the science and ideas behind machines that learn, decide, and sometimes even surprise their creators. Artificial intelligence, or AI, is the science of making machines that can do things that normally require human intelligence. This includes tasks like recognizing faces, understanding speech, making decisions, and even playing games. But AI isn't magic. It's built through programming, mathematics, and data. Arya imagined a robot that could talk like a human and help with homework. Her grandfather nodded. "That's one kind of AI, but there are many types." He explained that AI isn't just about robots. In fact, most AI systems are just computer programs running inside machines we already use, like phones, laptops, or even refrigerators. Her grandfather told her that AI comes in two main types: narrow AI and general AI. Narrow AI is the kind we see today. It's designed to do one specific task. For example, the AI in a smartphone that unlocks the screen by recognizing your face is only good at that one job. It can't cook or write a story. General AI, on the other hand, would be as smart as a human, able to learn anything and do many tasks. But this type of AI doesn't exist yet. It's more of a dream for now. Arya asked, "How do these machines learn?" "That's where machine learning comes in," her grandfather replied. Machine learning is a type of AI that learns from data instead of being told what to do step by step. Imagine teaching a dog to sit. You show it how, give it treats, and repeat. Over time, the dog learns. Machine learning works the same way. You feed it data and it finds patterns. For example, if you want a computer to recognize pictures of cats, you show it thousands of cat pictures. It starts to see what cats usually look like: furry, whiskers, pointy ears. Over time, it learns to tell a cat apart from a dog or a chair. The program that does this learning is called a model. A model is like a brain built by the computer using the data it was given. The more data it gets, the better it learns. But how does the computer know what a cat is? Arya asked. Her grandfather said, "That's thanks to something called a neural network. It's a method used in machine learning that's inspired by how our brains work. A neural network is made up of layers of tiny parts called neurons. These are not real brain cells, but math functions. Each neuron takes in numbers, does some math, and passes the result to the next layer of neurons. Imagine passing a note through a group of friends, and each one adds or changes a word before giving it to the next. By the end, the note may have transformed in a useful way. That's what a neural network does to data. It turns it into something meaningful, like recognizing a cat in a picture. The more layers a network has, the more complex patterns it can understand. When a network has many layers, it's called deep learning. To get a neural network to work, it needs to be trained. Training is the process where the model is shown lots of examples so it can learn. Training involves giving the model data and letting it guess something like whether a picture has a cat. At first, it guessed badly, but then it compares its guess to the correct answer. If it's wrong, it adjusts itself using a method called backpropagation. Backpropagation is like checking your math homework. If the answer is wrong, you go back, find where you messed up, and fix it. In AI, this helps the model improve step by step. This cycle of guessing, checking, and adjusting is repeated many times. The model slowly gets better at the task. "Can AI make mistakes?" Arya asked. "Oh yes," her grandfather said. "AI is smart in some ways, but not perfect. AI only learns from the data we give it. If the data is bad, the AI will be bad. This is called bias. For example, If a face recognition system is trained mostly on photos of light-skinned people, it might not work well on darker-skinned people. Also, AI doesn't really understand the world. It only sees patterns in numbers. It doesn't know what a cat feels like or why we love them. That's why AI can sometimes be fooled by simple tricks, like weird images that a human would never mistake for a cat. AI is everywhere, her grandfather explained. It helps recommend videos on YouTube, powers voice assistants like Siri or Alexa, drives some cars, and even helps doctors find diseases in scans. But not all AI is harmless. It can be used for spying, spreading fake news, or making decisions that affect people's lives, like who gets a loan or a job. That's why it's important for people to understand how AI works, so they can ask good questions and build it responsibly. Arya asked, "Will AI take over the world?" Her grandfather laughed. "Not like in the movies, but it will change the world. The future of AI depends on how people choose to use it. It can help solve big problems like climate change or disease, but it also needs rules and careful thinking. Just like fire or electricity, AI is a tool, a powerful one. If used wisely, it can do great good." Arya sat back, her mind buzzing. She had started the day wondering if machines could think. Now she knows that while they don't think like humans, they can do amazing things through learning, data, and clever programming. She smiled and said, "Maybe I'll build an AI someday." Her grandfather smiled too. "Just remember, it's not about making a machine smart. It's about making it useful and fair for everyone." And from that day on, Arya started her journey, not just to understand AI, but to shape it with care, creativity, and curiosity.